Everybody, welcome to your very first flipped classroom video of the year. So even when we return back to school, this is how you're going to be doing your learning throughout this entire school year. So instead of me being at the board and lecturing you at the board, we're now going to flip that, and you will get these short videos that can range anywhere from 8 to maybe 15 minutes long that will go over what we would have typically covered in class. And then instead of you being home and maybe being home alone with no one to help you while you're doing your homework and being stuck, you will now be doing all that work in the classroom. Right. And then in the classroom, you have all of your classmates that can help you, and you have me, the teacher, to help you as well. Right. So this is how it's going to be for the rest of the year. So when you're giving your videos, the first thing is I'm going to tell you what we're going to be learning about, and you'll have a title. So in this case, it's going to be the introduction to ratios. And in each video, you will have learning objectives, and the learning objectives are what is it that we're trying to learn in this video, that by the end of this video, that you'll have at least a foundational, an understanding, a baseline understanding. Right. So I don't expect you to master this video just because you watch this video. It's just that you have an understanding of what it is that we're learning. And when we come into class the next day, you know what to expect. All right. So what are learning objectives for today? Is students will know what the definition of a ratio is and how we can use a ratio instead of describing one number as a multiple of another. Meaning, instead of saying, oh, this is twice as large as that number, we can represent it as a ratio. All right. So it's just a way for us to describe it. And it's a way for us to describe these two quantities. So we're going to define what a ratio is and how we can use a ratio instead of a multiple. All right. The other thing that you will need to know is you will need to know the precise language and notation of writing a ratio. So I'm going to show you this to you now. So I'm going to use blue for this. So there are three ways that we can write our ratios. If I want to write my ratios of 3 to 2, I can write it as a fraction, 3 over 2. I can write it as a colon, 3, 2, 2, and I can literally write it with the word 2 in between. No matter how we write it, we will always say it as 3 to 2. So even if it's written as a fraction like this, we wouldn't say 3 over 2. We would say 3 to 2. That's the way that we talk about our ratios. All right. Even with the colon, we would still say 3 to 2. And here we would clearly just read the 3 to 2. All right. So we must be using the precise language, and we need to know how the different ways we can write them are. And then the last thing is students will understand that the order in which the ratio is written is important. So this 3 to 2 is not the same as if I were to write it as 2 to 3. And right now, you might not necessarily understand why this is so important and how these are different. But in a few sections, when we start solving word problems or solving problems that deal with ratios, you're going to see why it is really, really important that we understand that the order does matter, right? The red and the blue ratios are not all the same, even though we may be comparing the exact same quantities and the exact same items, but they're different depending on the order in which we write it. All right. And the good thing about these learning objectives is at the end of the video, you guys can come back and check them off that, yeah, I actually do understand these, or yes, I did learn about this, and I'm going to master it in our next video. All right, so those are our learning objectives. Today, it's just going to be an introduction to ratios. And then our next video, we'll start going over more problems with ratios and rewriting them and how they can appear in different ways. For now, we're just getting into an introduction. All right, so what is a ratio? Let's go over the definition of it. A ratio is a comparison of two quantities. All right, so it's allowing us to then look at two different things and compare their quantities, how many we have of them, how many there are of them. So a ratio is a comparison of two quantities. And then now let's consider the two quantities A and B. So we're just thinking, okay, any kind of quantities that we have, and we're just going to label them by a variable A and B, and they can represent whatever quantities we want. The ratio of A to B indicates that there are A units of the first quantity for every B units of the second quantity. All right, so that's just telling us how many we have of A in comparison to how many we have of B. All right, so it's allowing us to take these two different things and put them together and compare them in one mathematical statement. All right, so let's look at this image here. We have 4 oranges and we have 3 apples. If I say compare our oranges to apples and to create a ratio, then simply we will say, well, how many oranges do we have? We have 4, and we have 3 apples. So our ratio of oranges to apples is 4 to 3. Right? So it's allowing us to then take how many oranges we have, take how many apples we have, and then compare the quantities that we have. All right? If I were to say instead of oranges to apples, I said apples to oranges, this is where the order matters. So in this case, it would be, well, we have 3 apples, so we would do 3, 2, 4. All right, so the order in which we're comparing them, we're saying, well, we have 4 oranges for every 3 apples. All right, see how we're able to compare them? And it's allowing us to indicate how many units we have of the first quantity, in this case, oranges, for every units of the second quantity, apples. So we have 4 apples for every 3 oranges. Or I'm sorry, 4 oranges for every 3 apples. And what we can do with this is we can also use these to answer other questions, because then I can say, all right, well, if there are 4 oranges for every 3 apples, and then you count that there are 9 total apples at this store, well, how many oranges must there be? So it allows for us to answer some other questions and extend beyond just this ratio of 4 to 3. All right, but just know that a ratio is a comparison of 2 quantities. And it's telling us how many we have of the one quantity for every, for however many we have of the other. So for every 4 oranges, we have 3 apples. All right, everyone. So this is really, really, really important that you guys understand that it's a comparison of 2 quantities, and it's allowing us to say how many units we have of the first quantity for every units of the second. All right, it's really important that you understand this. Let's go ahead and move on to the next part. All right, so we're going to go through an example with this, and we're going to talk about this in a few different ways. All right, remember, this is just a basic introduction. At the end of this video, I do want us to be able to answer the question as what's the difference between a fraction of 1 over 2 and what's the difference of a ratio of 1 to 2. And to do that, we need to be able to talk about this and understand what a ratio is. So for the first example, the co-ed soccer team has 4 times as many boys on it as it has girls. We say the ratio of the number of boys to the number of girls on the team is 4 to 1. And like I said, we read this as 4 to 1. So that means if we were to look at this team, we know that since we have a ratio of 4 to 1 for boys to girls, that means that if we look out on the field, that we should see 4 boys and this 1 girl here. All right, so what we can do is we can start to create a table to start looking at this information. Right? And we can say that we have the number of boys we have is 4, the number of girls we have is 1, and the total number of players we have is 5. Something we're going to talk about in our next video is that we can create these ratios from part to part, meaning we can look at it specifically as just broken down into boys and girls. We can look at it as part to whole, meaning we can compare the number of boys to the total number of players, or we can compare whole to whole, meaning if we're looking at 2 separate different teams, right? But in this case, it's telling us that we have this ratio of 4 to 1, meaning that for every 1 girl we have 4 boys. Right? That's what this ratio is saying. That's what you need to be able to get out of this, that this ratio is simply comparing how many boys we have to how many girls. All right, but let me ask you a question. Does a soccer team only have 5 players, or are there more? Right? So depending on what you're playing at AIS, the U14s, we play 7. If you're playing on an official size field, that's 11. So in this case, this may not represent the actual number of boys and girls that we have on the team. So let me ask you a question. Let's say that we need to think about extending this. So what could be our next possible amount of boys and girls that we have? So if we have 4 boys for every 1 girl, well, what's our next one that we can do? Well, let's go ahead and say, well, we could have 8 boys. And if we have 8 boys, how many girls will we have? We would have 2. And the total number of players we would have in this case is 10. Let's keep going. What's another number of boys that we can have? Well, we can have 12. The next number of girls we could have is 3. And then in that case, the total will be 15. All right, so when we're talking about our ratios, one of the things that you're going to have to be able to identify is this ratio can represent an infinite amount of different possibilities that we have. The ratio is what it is in its simplest form. That's why when we're doing fractions, we always simplify as much as possible. That still holds true with our ratio. All right, when we talk about our ratios, we're going to write about them and talk about them in their simplest form. And we can use that concept that 4 to 1 means for every 4 boys we have 1 girl. We can use that to extend it to talk about instances where we have more than just a 5 number of players. So what happens when we did have 15 people on our team? How many boys and girls would we have then in order for us to have a ratio of 4 to 1? All right, so it's just allowing us to compare the boys that we have versus the girls that we have on this team. And as we showed here, This ratio, all of these ratios are still holding true. They're all ratio of 4-1, even though it's presented to us in different ways, right? So in this case, we would have 4-1. Here it would be 8-2, and here it's 12-3. All of these are still representing the exact same scenario, but it's allowing us to extend our ratio to look at where we might have more people than just that 5 total. And as we talked about and what our learning objectives are, is it is really important for us to be able to know how to write these ratios and not always to say that it is 4 times as large, because that's one of the ways that some people might have described this, that we have 4 times as many boys as we do girls in our team. But when we're trying to use this to extend and solve a question later on, it may not be as easy for you to answer that if you're just writing it out as a multiplicative number, meaning that 4 times as large. So writing it as this ratio allows for us to write out exactly how we're comparing these two, how many boys to girls. All right, it allows us to see it a little bit better than just saying it's 4 times as large or 4 times as many. All right, so it's allowing us to write this out as a ratio to compare the number of boys that we have to the number of girls that we have. And it allows for us to extend this beyond just that one ratio of 4-1. All right, now in this next example, you guys are going to answer this question for me, but it's going to be, what if instead of being 4 boys to 1 girls, what if it's 3-2? What is another ratio that you can create that can still hold true with this same ratio, that is 3 boys to 2 girls? So you're going to write this out as your answer for me in your Edpuzzle video. All right, so just seeing if you can take what we just talked about and extend it. So now we're saying that we have 3 boys for every 2 girls. Well, what is another ratio that we can actually have here that you can write it out explicitly for me? All right, so one of the things I want to go through as well is that you need to understand is the difference from when we have a fraction that is 1/2 versus when we have a ratio that is written as 1-2, but as a fraction. All right, just so you know, one of the reasons why we were practicing our fractions before is because all of the same computational things that you can do with fractions, the way that you add fractions, multiply, divide, all of that is still true with ratios. So all of the rules that you've learned for how to add, subtract, multiply, divide fractions, all of that still holds true for a ratio. Right? Just like how we simplify fractions, we still simplify ratios. So all of that computational skills are all the same, but they mean 2 completely different things. When we have a fraction of 1/2, what this is saying is parts over the whole. So it's meaning, well, how many pieces would make up an entire whole part of this? In this case, for 1/2, that means there's 2. And then for the parts, it's how many do we have? So we have 1. So this is saying that we have 1 out of 2. So, or that we have 0.5, or that we have 50%. All right. So it's saying what this fraction represents. It's saying how many parts we have versus how many parts make up an entire whole piece. All right. So that's what we're looking at with a fraction. Whereas a ratio, it is not necessarily how many parts we have versus the whole. In this case, if it's 1-2 and we're comparing boys to girls, well, this is just telling us how many boys we have versus how many girls we have. And if we actually want to talk about the total, the boys versus the total wouldn't be 1-2 like it would be in a fraction. This is actually 1-3 if we're comparing to the total, because if we have 1 boy and 2 girls, we have 3 total people that we're comparing it to. So you see here that when we are dealing with our fraction of 1/2, that 2 actually represents how many pieces would make up an entire whole piece. And then that 1 is telling us how many pieces we are currently having of that whole piece, or what percentage we might have of that fraction. Whereas when we're looking at it as a ratio, we're comparing how many we have of one versus how many we have of the other. So in this case, it's not necessarily how many we have, but it's what makes up an entire whole piece. How many pieces we could break that candy bar into. We could break it into 2 pieces. Well, we have 1 of those 2 pieces. What this is saying is that, well, we have 1 boy versus 2 girls. So it's not necessarily what makes up a whole. All right, so that's a huge difference that you guys have to understand with that. A ratio, we're comparing 2 different quantities, boys and girls, whereas a fraction, we're saying how many we have out of the entire piece, how many we have out of how many pieces we have out of the entire whole part. All right, so that's the really, really important difference that you have to see with these and what they're actually telling us. They're the same in how we will perform all of our computational skills, but they're completely different in what they're representing. Okay, and just to go over real quick what this video is about, This part we're going to talk about in person. I don't want to talk about in the video just yet because I want to see if you guys know why. But a ratio is an ordered pair of numbers which are not both zero. So they both cannot be zero. All right. And we're going to talk about why they both can't be zero and why you think that in our call or in class. A ratio is denoted A to B to indicate the order of the numbers. The number of A is the first and the number of B is the second. Remember, order matters. B to A is not the same ratio as A to B. All right, they may be telling us the same information about them, but it's written differently. The order of numbers is important to the meaning of the ratio. Switching the numbers changes the relationship. Right? Exactly what we were just saying. If we're going from boys to girls and girls to boys, it's not the same. The description of the ratio relationship tells us the correct order of the numbers in the ratio. So that's why it's very, very important that you guys understand that order matters. A to B is not the same as B to A. Right? A to B is not B to A. And once we start going through some examples of how to solve for this and applying it, you'll see why it's a big deal not to put them the same, or how you would know that they're not the same. All right, that is it for this video.